Hello, I welcome you all to this another interesting screencast. And the problem reads: the force F is equal to 30 newtons, and the earth's on the bracket is shown. Determine the moment of the force about the AA axis of the pipe. Also determine the coordinate direction angles of F in order to produce the maximum moment about the AA axis. And what is this moment? This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right. So we have the first case. Okay, we are being asked to find the moment about the AA axis. So you can solve this either using the scalar or using the vector. It's up to you. Of course, you want to go for the easiest, and the easiest here I feel is the vector. I mean the scalar. But if you want to use the other method, well and good, you still arrive at the same answer. All right. So what do we have? We have 30 there, cos 60, which is just equal to 15. We have 30 there, cos 60, which is also just equal to 15. Then we have 30 there, cos 45. Alright. So there are only going to be two forces that will participate in contributing to the moment about the AA axis. And using the right hand thumb rule, both of them will give us positive. And these are the components in the Z and in the X. So MAA, which is moment about the A axis, will be equal to 30 cos 45 times the lever arm, which is 100, converting 100 millimeters to meters, 0.1, plus 15 cos 15 times the lever arm, which is 0.15. Therefore, the AA moment about the AA axis will be equal to 30 cos 45 by 0.1 plus 15 by 0.15. So this gives us a 4.37 Newton meters. Okay, so let's go to case number 2. Case number 2, we have been asked to determine the coordinate direction angles of F in order to produce a maximum moment about the AA axis. So for us to produce a maximum moment about the AA axis, okay, so if this is the force, all right, if this is the force, then we expect this angle there to be 90. Okay, and therefore the maximum moment, and this is our D, which will be our lever arm, right? And the maximum moment therefore will occur when F is perpendicular to D. Okay, right. And then finding the coordinate direction angles, we know that this slope here, if this point is A, then this one is B. Therefore here, this one will be B, this one will be A. Okay, so if this has a negative slope, and if this is our coordinate system like this, y, x, so if this has a negative slope, then this other one here will have a positive slope. So positive slope, this one negative slope. And then we know that if we code this as our line 1, then we code this as our line 2, then the product of the two gradients gives us negative what? 1. And if we use the dot product, unit vector 1, okay, dot unit vector 2, using dot product, this gives us 0 when two vectors are perpendicular to each other. So we have a lot of methods really on how to tackle this particular problem. But we are going to use this one A, B, B, C. A, B, you've seen how they change the coordinates. The same ones, but they will just change. Alright. So we are going to use this coordinates let alone to find the direction. Right, let me just redraw this. I just extend this line. I extend this line like so. Alright, so this is X, this is Y, and this is Z. And then if this point here is A, if this is A, this is B, and then this one there, this one here is going to be equal to RAB. Okay, so let's assume A is our reference in this particular case. A is our reference, and A is our reference, and is 0, 0, 0. And B therefore will be minus 0.1 in the Y 0, then in the Z 0.15, and therefore RAB will be equal to minus 0.1 I plus 0.15 J, and magnitude of RAB will be equal to 0.1 squared plus 0.15 squared. Okay, so this gives us 0.1803. Alright, then unit vector along AB, we need that. This is just going to be equal to minus 0.1 I divided by 1803 plus 0.15 J divided by 0.1803. Right, there we go. So like we said, we are going to dot two of these vectors along this position vector AB. So we'll have one unit vector from A to B and another unit vector along F, this new F that is perpendicular to AB, right? So we'll have this expression is UAB dot UF. This is the unit vector along the new force. We are saying this is supposed to be equal to 0. Okay. So if UAB is minus 0.1 I divided by 0.183 plus 0.15 J divided by 0.1803, and this particular line has a negative slope, therefore we expect the coordinates for UF, if it's perpendicular, they will have the same values but in the opposite direction. So in the X, they will exchange. It will be 0.15 I divided by 0. Like so, then plus 0.1. This is K. Sorry, this one here, it is K. Okay, it's a kth component. Sorry about that. Okay, so this one is a kth component. This is K, and this is K, right? So this is going to be equal to 0.1 K divided by 0.1803. And then we are saying if we did the multiplication of this, it is going to give us a 0. Alright. We know that, of course, so our UF, like we said, is just this. Okay. Just that, right? It is just that. Okay. Remember where we got this concept? We said when you have two lines, you have one line like this. Let's say you have one line like this. You have another line like in our case. And then you have, you're saying they are perpendicular to each other. Then this has a negative slope. You have an A there, you have B. This one will have a positive slope if our coordinate system is like this. Okay, so this one will become our B, and then this one will become our A. So this is what has happened here, this change. Okay, we've seen this change. This is what has happened. All right. Okay, great. So once we know this, therefore, it is easier now to say our cos alpha, if this is alpha, let me rub these angles here and indicate different angles here. So let's call this one here with x-axis as our alpha, and then we call this one here, this angle there, as our beta, and then we call this one here as our gamma. All right. So let me write this completely so that I indicate also the other component. So I will have plus a 0j divided by 0.1803, then plus 0.1 k. We need that when it comes to the directions, divided by 0.1803. So our cos alpha therefore will be equal to 0.15 divided by 0.1803. Our cos beta will be equal to 0 divided by 0.18 divided by 3. And our cos gamma will be equal to 0.1 divided by 0.1803. Therefore, alpha will be equal to, these are now the directional angles we want to find, 0.15 divided by 0.1803. Arc cos of that is equal to 33.70 degrees. Beta, that is 90, right? Arc cos or cos inverse of 0, it is just 90 degrees. Okay, and then gamma 0.1 divided by 0.1803, and then cos inverse of that, it gives us a 56.31 degrees. Okay, 0.15. Let me just check this one once more. All right, so we found the directional angles for f. For the new f, the magnitude remains as 30. These are just directional angles that will give us the maximum moment that is about the AA axis. All right, and what is this moment? Again, we can either use scalar. We're going to use both of them. So if we use the scalar approach, all right, then we are going to say this maximum moment about the AA axis is going to be equal to the force itself, 30 force times the distance, which is going to be equal to 30 times, what is the distance, because these are perpendicular to each other, 30, the magnitude of the position vector or the vector arm is what? It is 0.1803, and therefore this m max about the AA axis is just going to be equal to 30 times 0.1803, 1803. We get a 5.41 Newton meters. All right. So what if we wanted to use the vector approach? The vector approach will still find the same answer. The vector approach, so the vector approach, we have the the unit vector along the the unit vector along the AA axis is just equal to J. Okay, so this gives us maximum moment M max is going to be equal to the unit vector along the AA axis dot the position vector itself, which is the moment arm RAB, okay, cross the force. Okay, so RAB cross the force. All right, so if you plugged in all the equations, the equations, let me just move this a little bit up. It's like space is not our best ally. Space is not our best ally. Okay, and then let me just move this a little bit, maybe this side. I do this like this. Okay, space has become a little bit limited. Great. And then we try and move this up so that I have a little bit of space, because we want to solve this using two approaches. All right, what is our force? Let's write our force. Our force vector is going to be equal to, using this new, it is 30 cos alpha. What is our alpha? Is 37.70 degrees plus 30 cos alpha cos beta, which is 90 J. This is I. plus 30 cos 90 j, okay, plus 30 cos what, 56.31 k. All right, and therefore this force is just going to be equal to, if we are to work it out, so we have 30 by 33.70, 30 cos 33.70 gives us a 24.96 I plus 0, of course, kj plus 30 cos 56.31, which is a 16.64 k. Therefore, our maximum moment about the AA axis is just going to be equal to, using this tool, so we have UAA, which is the unit vector along the AA axis, is just 0, 1, 0. RAB, it is just minus 0.1, then 0, then 0.15. Okay, and then the F, the force, it is a 24.96, and then 0, and then 16.64. So what we have, so we have 0 by 0 minus, okay, so 0 by 0 minus 1. What do we have on 1? We have minus 0.1 by 16.64, minus 0.15 by 24.96. So this gives us a 5.408 plus 0, 0, this one also just 0 there. Therefore, our maximum moment using this vector notation, vector method, gives us a value of, this one is minus, there's a minus inside there, okay, so 1, this, yes, minus, so this one gives us a 5.41 Newton meters, which is just similar to what we found. All right, I think this is about it. I hope the video was helpful. Let me just outline the solutions. So we have the maximum moment. Let me start with first case. We have the moment about AA axis given those angles that were given initially, 60 degrees in the X and Y and 45 with respect to the Z. Then we have the directional angles that we just calculated. That will give us the maximum moment about the axis. Okay, and then finally, using the scalar approach, we found the maximum moment about the AA axis. This is where the force is perpendicular to the lever arm, and when we use the vector approach, we still found the same result. Okay, so this is about it, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screen